Good day, everyone. My name is Ravi Subramanian. I'm the Director for Industry Solutions for HiveMQ, and we provide enterprise-grade MQTT brokers to support various use cases, including connected cars. Today, we are going to be talking about how our solution enables the connected car experience. So here is the demo. In this case, we talk about a company named the Car Company, and they want to be able to connect their vehicles to the enterprise and provide all of these different experiences like personal in-vehicle experiences, remote diagnostics, remote vehicle control, predictive maintenance, and things like that. So it's all about ensuring that all of the vehicles are able to talk to their enterprise in a scalable, reliable manner. Historically, vehicle is actually hardware-based. So it's like various hardware subsystems. But slowly that shift from the hardware to software is happening. So most of the subsystems are more software-based than hardware-based. So software-defined vehicle is all about software defining how vehicle subsystems communicate with each other and with the enterprise. And MQTT is very apt in the software-defined vehicle space. Now let's look at the flow. So this is kind of like the typical flow of a connected car experience. So I would say software-defined vehicle is on the left side, and then the connected car is when you actually take that and get that into the more of the enterprise side of things. So if you look at the vehicle subsystem, these are the different typical subsystems that you encounter within the vehicle: the tire, collision, motor, tank, and other subsystems. And these all talk to like an onboard computer, the vehicle subsystem that has all of the information about all of these different subsystems. It has a processor. It has the ability to like interpret all of the data. And then it also has the ability to post the data over MQTT, over 4G, 5G. We interact with this onboard computer to be able to bring that data into our HiveMQ cloud. And then the HiveMQ cloud is then what is sending that information to various applications. Typical applications would be a digital twin. If I want to build a digital twin of my vehicle or my vehicle subsystem, if I'm having a fleet of vehicles, if you will, if I want to do machine learning on the cloud or on the enterprise side of things, if I want to do some database calculations, or if I want to send it to the data lake to be able to do some advanced applications. And this also includes mobile experiences. Typically, off of digital twin, you want to have some mobile device that is able to control some of the vehicle subsystems or be able to see some of the information on the vehicle subsystem. The unified namespace is an upcoming concept that would also be ripe for a connected car experience, like especially if you have a fleet of vehicles. So you talk about like different cars, and then you have different VIN numbers. And then within those vehicles, you have different subsystems like the location, telemetry, and then motors. And that goes into different sensors, airbags, and then it goes into like things that you want to track. That's what unified namespace is all about. It's like conceptualizing the data so that it can easily be combined with other information within your enterprise. Data Hub is basically an experience that we have. It's all about ensuring that the data is high quality, it's normalized, it's conceptualized, and it's ready for you for prime time usage for doing digital twins or any advanced applications that you want to run. So the first thing in Data Hub, I would point to is schemas. Schemas is basically like scripts or XMLs that you create to say to this particular schema, what am I trying to achieve? For the connected car experience, I want to make sure that the vehicle pressures are between 30 and 50. That is kind of like the definition. That's the schema. And then the schema is taken and then applied to data policies. Like for example, in this case, the pressure validation data policy would take that schema, and then you want to validate that schema. And then what action do you want to take on failure? So if it's a bad pressure, then I want to update the metric on the bad pressure. So the metric name is unsuccessful message. On success, what do I want to do? I want to increase the successful message metric by 1. And then there is another thing called behavioral policy where, okay, I want to restrict the number of messages posted by a client to a maximum number of 100 publishers. So because I don't want it to hog the bandwidth, so I want it to be only 100. Beyond 100, I don't want it to publish anymore. Thank you everyone for participating in this demo. I hope you found it to be useful. I'll be back again for more similar demos on how HiveMQ helps various industries. Thank you.